Hi everyone, how are you all? कैसा गया गेट का एग्जाम? हाउ वाज दिस गेट 2023 कंप्यूटर साइंस पेपर? व्हाट डू यू थिंक? So let's discuss about this paper, the toughness level, the difficulty level, and some questions we can discuss, some answers we can discuss. So please share with everyone. Please share with all the GATE computer science aspirants. So let's start the discussion. So how did it go? What do you think? Was it hard, easy, moderate? What do you think about the level of the paper? The difficulty level of this GATE 2023 paper? Let everyone join. So Subham is saying easy paper. Himanshu easy. So yes, actually it was very easy paper, and you can see there was a SQL question for 2 marks. There was very easy SQL question in which basically the question was asking how many female students are there who have marks more than 65. Okay, and for that question answer will be just 2, and that was 2 mark question. That was a 2 mark question. So from that question you can just see that the paper was very easy. The questions were direct questions. There was no question from the decidability. From the theory of computation there was no creative question. Theory of computation was very easy, extremely easy theory of computation. So let's discuss about this paper. Okay, so the of course someone is saying, sir, someone else is also online. So yes, every institute will be online, but everyone knows where you will get the most correct analysis. Okay, where you get the most trustworthy analysis, that everyone knows for the last 5 or 6 years. So gate overflow basically, and now gate overflow plus go classes. So for the most trustworthy analysis you can join here. Please share the session with everyone, with all the with all the gate students, in all the telegram groups, your WhatsApp groups. Please share the link of this session. Let's discuss. We will discuss like the difficulty level of every subject, and some questions also we will discuss. Answers, questions, everything we will discuss. Okay, so I will provide you as much as possible, as much analysis as possible. Okay, maximum analysis possible I will provide you. Then we will have part 2. This is your gate 2023 analysis part 1, and after that we will have part 2. In that part 2 we will discuss the remaining questions. Those questions that I will not discuss, that I will not be able to discuss in this part 1, those we will discuss in the part 2. So let's see. So you first let me tell you the first question many students are asking. Many students might be thinking, sir, what was the difficulty level? Correct, sir. What was the difficulty level? Was the paper hard, easy? So this is my analysis. Let me tell you that this was very easy paper. This was really really very easy paper. I can say that for the last 6 years, I think this was the easiest paper. Okay, difficulty level will be, I think, almost similar to gate 9, almost similar to gate 2019 2020. Okay, those were very easy papers. Gate 2020, gate 2019, those like these were actually easy papers. So I think the difficulty level will be almost close to those exams. And let me tell you, in these exams the topper had, in these exams the topper almost had 92 marks, almost 92 marks. So this is my analysis, that I will not be surprised if in this 2023, in this 2023 exam, I will not be surprised. I will definitely, topper will get more than 90 marks. Okay, definitely the topper is going to get more than 90 marks, and I will not be surprised if the topper gets more than 92 also. If the topper gets more than 92 also, I will not be surprised in this 2023 exam. I can tell you that this will definitely happen. the topper will definitely get more than 90 marks, maybe 92 to 95 marks somewhere. Okay, so because it was a easy paper, so of course cutoff will be very high. Okay, this is this is a safe analysis. Of course I can also write like the topper may get 95 marks. It is possible topper may get 95 marks. Okay, it is possible, it is definitely possible. I will not be surprised, like if the topper gets 95 or more than 95 marks also, I will not be surprised, because the paper was seriously very easy. The straightforward questions were there. Okay, in the questions very few questions needed analysis, very few questions were there which needed your, I can say, which needed some tricky concept. Okay, so this is my analysis of the difficulty level. This is the first thing that I wanted to discuss, what is the difficulty level. So this was easy paper, very easy paper actually. Okay, the second thing, what will be the cutoff? So as I told you, the topper is expected to get more than 90 marks, and I can tell you one thing, that if you are getting around 70 marks, if you are getting around 70 marks, you are safe. You are safe for, I think, top 100. I think you are safe for top 100 if you are getting, more than 70 marks. Okay, greater than or equal to 70 marks, then I think this will happen. Okay, you will be around top 100. Okay, it is possible that, okay, around top 100 you will be. Let me tell you that in this GATE 2020, for 74 marks there was 53 rank. For 74 marks in this GATE 2020, for 74 marks the rank was 53, and this was this is my because this is my rank. In GATE 2020 I got 74 marks and I got 53 rank. Similarly I can say, so this is the analysis. I can say that if you are getting around 70 marks, okay, greater than or equal to 70 marks, then definitely you are in the top 100. You will definitely be in the top 100. Okay, so basically how many of you are satisfied with this paper? Like, how many of you are satisfied with your attempt of this paper? How many of you are satisfied that you are feeling satisfied after this GATE exam? How many of you are feeling satisfied that yes, this was a nice paper? I am not saying that this was really nice paper. It was easy, but it was nice paper. The questions were very nice, well framed questions. Did you notice? Did you notice the questions were very well framed questions? Every detail was given in the question. Even they were, in every question they were also saying that what is K. For example, if they are writing 64 KB, then in the bracket they are writing that 1 KB is equal to 1024 bytes. So you can see this was a very well framed paper. So this actually, when the paper is well framed, then the paper is very nice. So this is my analysis, that it was really a nice paper. Really nice paper, nice exam, nice paper, nice questions. Okay, this was really well framed. Every question was well framed. Did you notice this? In every question they were giving all the details that you need. Every detail was given. Even there was one question, why I am saying this is very well framed. This was so well framed that in one question the graph was given as finite. This information was also given, that the graph is finite. Generally, if you notice, this information is not given, but this information was also given. So it was really well framed questions. Whatever whatever question you check, every question was very well framed. Okay, so this was really a nice paper. And is there anyone who is feeling satisfied that yes, my exam went very good, I did all the questions that I could do? So what do you think? Was time sufficient? Was the time sufficient? Let's discuss the next thing. So what we have seen so far, we have seen the difficulty level. The difficulty level was mostly easy, or I can say easy to moderate, There was no question from the hard topics. There was no question from decidability. From the decidability there was no question. From the synchronization there was very easy question. From multi-level paging there was very easy question. Okay, so this is the difficulty level. I can say easy to moderate. Second point, if you are getting more than 70 marks or 70 marks, then you are in the top 100. Third point, the questions are very well framed. Every question was very well framed. Okay, and the next point I will discuss, the questions I will discuss. Many students are asking what is the answer for this question, for that question I will discuss. But before that, let's see, what do you think? Was the paper lengthy? Was the time sufficient? Was the time enough? What do you think? Was the paper lengthy or the time enough? I think the time was enough. I think the answer would be yes, the time was enough. Okay, so you can definitely go through all the 65 questions within the 180 minutes. I'm not saying that you will be able to solve 65 questions. Of course, no one can solve all the 65 questions. Some questions definitely you will not be able to solve. But what I'm saying that you can definitely go through all the 65 questions in the 180 minutes. So these 65 questions you can go through. These 65 minutes, these 65 questions you can go through. You can go through in 180 minutes. So this was actually, time was enough. So there is no problem of time. The question, very few questions were lengthy. Very few questions were lengthy. How many questions were lengthy? What do you think? Questions like, how many questions were lengthy? Very few questions actually were lengthy, and even the lengthy questions were easy. Okay, even the lengthy questions were easy. Okay, so many lengthy questions, actually lengthy questions were easy. If you notice, there was some lengthy questions were there, but actually the lengthy questions were actually easy. If you attempt them, they were actually easy. In the DBMS, there was one question from the indexing. The question was asking how many blocks you need to access. You are applying the binary search. So that was one question. The question was lengthy, but the question was very easy. Okay. So shall we start with the discussion of questions? Shall we start the discussion of questions? Let me know. We can discuss the questions and their answers. These things we can discuss. But please like and share the session. Please like the session and share with all the GATE aspirants. Let's start the discussion of questions. I will also give you the answers of some questions. As many questions as I remember, I will tell you the answer. Okay. So for as many questions as possible, we can discuss the answer immediately. Like immediately we can discuss the answers. What will be the answers? We can discuss immediately. Please like and share the session so that more students will be able to see. Okay, more students will get the correct analysis. Let me tell you, the analysis that you are getting from me. And so basically right now, let me introduce myself to those students who are coming for the first time on the Go Classes YouTube channel. So let me introduce myself so that you can feel satisfied that you are getting very trustworthy analysis. So let me introduce myself. My name is Deepak Poonia from ISC Bangalore. I am ISC Bangalore pass out. Also, in the GATE exam, many times I have secured top rank in the GATE exam. In GATE Computer Science, many times I have secured GATE top rank, like All India rank 53, All India rank 67, All India rank 206, All India rank 256, etc. So basically, the analysis that you are getting, you will be getting the most trustworthy analysis. You can basically please share with all the GATE aspirants for the complete and clear analysis, for the most correct analysis. Please share with the GATE aspirants. Please like and share with the GATE aspirants. Now we can start the discussion of session, discussion of questions. Okay, shall we start? Let's start. As many questions as we can discuss, let's start one by one. One by one we will discuss. Okay. Mitesh is also here. Mitesh Khemani, he is All India rank 10 of the last year. So Mitesh is saying that this time rank will be decided by silly mistake. That is very excellent point. So in the comments you can check, Mitesh is also here, and so he is All India rank 10 from GATE 2022, and the statement is very good because that is correct. When the paper is easy, let me tell you, when you have a easy paper, then the rank is decided by the silly mistakes that you are doing. In the easy paper, rank will be decided by silly mistakes. The rank will be actually decided by how many silly mistakes you are making. Decided by silly mistakes. Do you remember my session on silly mistakes? I took 1 hour session only on the silly mistakes. I was telling you to take care of the silly mistake, because when the paper is very easy, when the paper will be easy, when the easy paper you have, then rank, it will be decided by the silly mistake, how many silly mistakes you are making. So if you are making very less silly mistake, maybe 2 3 silly mistake if you are making, that is fine. Okay, 2 3 silly mistake is fine, there is no problem, 2 3 silly mistake is okay. But if you are making more silly mistakes, that is not good. If you are making more silly mistakes, that will not be good. So rank will be decided by the silly mistakes. How many silly mistakes you did, you tell me. But let's discuss the questions. Some questions we can discuss one by one. So let's start with the theory of computation. Let's start with the theory of computation, because this was very easy. The questions were very easy from the theory of computation subject. There was no decidability question. So first let me give you the general analysis of theory of computation. There was no question from decidability. Not a single question from decidability. This never happens. This actually never happens. Every year there is at least one question from decidability, but this year there was no question from decidability. And this was very sad thing actually, that this is also telling you that the paper was easy. So in the theory of computation, no question from decidability, no question from pumping lemma, no question from pumping lemma. So basically there was no complicated question. There was no question from pumping lemma. There was one question from PDA. So let's discuss what were the questions. Let's discuss. One question was from PDA, push down automata. There was one question. Let's discuss what is the answer for this question. Do you remember there was one question from the push down automata? What do you think? What do you think? In this push down automata, there was MCQ question. There was a MCQ question. I think that was a 2-mark question. What do you think? What is the answer for that question? For this push down automata question, the answer that was the answer, if I remember correctly, it was a power m some b power n, where this n will be less than m. Okay, so this will be less than m, this will be greater than or equal to 0. So I think this was the answer. What do you think? I think this was the answer, a power m b power n. There was a push down automata question. There was a PDA p. A push down automata was given to you. A PDA p was given to you. And for that question, I think the answer will be this. Because that push down automata, if you notice, number of b must be less than number of a. This must happen. Number of b must be less than number of a. And you can accept empty string should not be accepted. Okay, in this push down automata, empty string is not accepted. A power a plus is accepted. And if the b is coming, then number of b will be less than number of a. Okay, number of b will be less than number of a. So for this question, the answer was this. Okay, a was compulsory. You must have a. You cannot accept empty string. Empty string was not accepted. Okay, empty string was not accepted. The reason is empty string is not accepted. You must have at least one a. So the answer was something like this. And there was only one option. This type of option only one. So let me just tell you, there was a PDF. Some PDF was given to you. Some PDF of this format was given. And basically for every a you were pushing a. If a is coming, okay, then you are basically, if you see this symbol, then you are pushing this a, you are pushing. If another a is coming, and if capital A is there, then another a you are pushing. Okay, so basically the alphabet, let me tell you, the alphabet was this. The alphabet was a comma b, and the tape alphabet was this. The tape alphabet was a comma this bottom of the stack symbol. PUC saying chat bhi read karo. Yes, I'm reading the chat. I'm reading the chat. The question was something like this, and the question was that if you have a, then whatever, without reading you can just pop it, and in this state you are basically popping all the a's. In this state you are popping all the a's. Let me just create the entire push down automata. The entire push down automata was something like this: b a epsilon, and then you must have, without reading anything, you must have a, then you do this. I think this was the push down automata. What do you think? I think this was the push down automata without reading anything, and it was accepting by the empty stack. This was your push down automata, the complete push down automata I have created, and acceptance by empty stack. Acceptance by empty stack. The acceptance was by empty stack. So this was your question. Now in this question you can easily see that empty string is not accepted. Okay, empty string is not going to accept it because you cannot accept empty string, because on the bottom you have this symbol. You must pop this symbol, right? Okay, this symbol you must pop. Empty string you cannot accept. Very simple. So this string cannot be accepted. The reason is very simple. The reason is this, that initially your stack has this. Your stack has this. So this is your bottom of the stack symbol. This is bottom of the stack symbol. So because the acceptance is by empty stack, so that is the reason you must pop it. Okay, you must pop it. So very simple, that in this question empty string will not be accepted. A plus is accepted. A plus, if you have a plus, that will be accepted. And you can notice that if you have if you have something like a power m, b power n, then you can notice here that you must have at least one extra a. Okay, so I can say that this n will be less than m. So this is the complete explanation, and this was your answer. So please tell me, did you do this answer or did you do some silly mistake? In this question, TOC question number 1, TOC, the push down automata question, 2 mark question, did you do some silly mistake or did you do this correctly? Let me know. A very simple question from push down automata, very simple question, very basic question actually. I can put this question I can put in the category of easy, because really this was a standard question of push down automata. This was a standard question of push down automata. There is no creativity basically. These type of questions we always solve. Okay, this was a standard question from the push down automata. So this was an easy question. You can easily solve this question, and this was the answer. Let's discuss the next question. The second question, there was one question about there is a grammar. A grammar was given to you. So if you remember, there was a question where this grammar was given A, S, B, then you go to X, then this X is going to AX, XB, AB. Do you remember this question we have taken in our Go classes, lecture? You can watch the Go classes lecture if anyone. Do you remember I gave you this question, that if you have this type of grammar AA, BA, AB, then this will produce A plus B whole star. This is going to produce A plus B whole star. This is standard grammar for if you have AA, BA. If you have this type of grammar, this will create A plus B whole star. But I told you one variation. Do you remember? Is there anyone who remembers this? Is there anyone who remembers this? I told you one variation where I told you that it is like AA, then so something like this, AA, then AB, and then A or B. What was the language for this? For this grammar, if you have this grammar, what is the language? What do you think? If your grammar is this, AA, then AB, then AB. So if you see, the language will be A power N, B power M. This will be the language. Okay, the language is going to be A power N, B power M. This is going to be the language where one of them is where either N is greater than or equal to 1 or M is greater than or equal to 1. So this variation we have already done in our Go classes theory of computation lecture. This variation, you can check it out. This variation I gave you as a variation I gave you, because this was the standard grammar for sigma star. A goes to A derives AA, BA, AB. So this was standard grammar for A plus B whole star. But this was variation that we created, that if you do like this, AA, AB, then the grammar that will be created will be A power N, B power N, because the reason is very simple. The reason is very simple. After B, A cannot come. In this A, after B, once you have B, then A cannot come. Okay, because if you, for example, you can start with A, then you can do something, or you can end with B. So basically you can never get A after B. This you can never get. This you can never get. You can check it out. So anyway, this is a variation. So in this question also, you can notice this was the grammar, and for this grammar, what X will generate? What X will generate? X will generate A power n, B power m. Okay, I can say, for example, A power m, B power n, where either m is greater than or equal to 1 or n is greater than or equal to 1. Right? So tell me, what S will generate? What S is going to generate? Remember, S is going to generate equal number of A equal number of B. Means A power P, then B power P, and then in middle, what X will generate? In middle, what X is going to generate? Okay? So you tell me, what is the final language in this situation? Like, in this situation, what is going to be the final language? So this is your grammar. S goes to ASB X, and this X goes to AX, XB, AB. This was your grammar. So for this grammar, ultimately your language will be what? Ultimately your language will be something like A power P, B power P, and then in between whatever X will generate. And what X is generating? X is generating A power m, B power n, where either m is greater than or equal to 1, either this is greater than or equal to 1, or this is greater than or equal to 1. So tell me, finally, what will be the language? Let me tell you, actually you don't need this, because everything that starts with everything of this format is already generated. You can notice that your language will be this only, A power m, B power n. Your language will be this only, because everything you can generate of this format, everything you can generate, m is greater than or equal to 1 or n is greater than or equal to 1. Everything of this format is generated. Yes or no? In this language, everything of this format is generated. Actually, this was a very good question, but actually this is unnecessary. This is unnecessary. The reason is very simple. Let me tell you the reason. Actually, this does not matter. This A power P, B power P, this does not matter. Why? Because you can directly go to X and you can generate everything of this format. Please tell me, did you understand what I am saying? I am saying that this A power P, this B power P, this is useless. This A power P, this is B power P, this is actually, I can say, redundant. This is, I can say, useless. You can call it useless. Why this is useless? The reason is very simple, that because you can directly go to X and you can generate every string of this format, A power m, B power n, every string of this format you can generate. Clear? Please tell me. Every string of this format you can generate. The reason is very simple, because this is useless. This A power P, this A power P, this is useless. This is useless because you can directly go to X. This X you can directly go and you can generate. Do you remember in All India Mock Test 1, All India Mock Test 2, this type of questions I was asking? Do you remember? Many times I was asking this type of question. In All India Mock Test 2 and All India Mock Test 3, this question was there. Do you remember this question? A power m, or I can say this question, A power n, B power n, and there was W. And this W belonging to sigma star. This W belonging to sigma star. Do you remember this question? Yes or no? This question, do you remember? In All India Mock Test 3 also there was a similar question in All India Mock Test, and there was one question, A power K W. Okay, W contains at least K A's. Actually, both of them were regular. Do you remember? This was also regular. This was also regular. This was also regular. Both of them were regular languages. Okay, so this type of question, actually this type of question I had already given to you. This type of similar question 2 times in Go Classes All India Mock Test 2, in Go Classes All India Mock Test 3. You can check it out. 2 times this type of question I gave you, so that you can see what is happening, so that you can understand the language. First you understand the language, then you solve the question. Okay, without understanding the language, do not solve the question. Okay, please see, if you do like this, the A power P, B power P, there is comparison here. Okay, there is comparison here, there is comparison here. So this is non-regular. There is comparison here, and comparison means non-regular. And comparison means non-regular. This is stupidity. This is called stupidity. This is called stupidity. Okay, there are many good ways to prove that it is non-regular. You can use pumping lemma, you can use Myhill-Nerod theorem. This type of logic is stupid. This type of logic is stupid. And just to tell you that this logic is stupid, I gave you two questions in the All India mock test 2 and 3. Do you remember? This logic is stupid. Just to tell you that this logic is stupid, just to give you the idea, just to make you ready for this type of question, I gave you these two questions, a power n, b power n, and in between you have w. Okay, and something like n greater than equal to 1, something like this. And here a power k w, and here also k greater than or equal to 1. These two languages are regular. Both of them are regular. Similarly, here also in this question, let me tell you, in this question also. So finally, let's come back to the question. So this 2023 GATE 2023, this TOC question. Let's come to this TOC question. So this grammar was given to you. Let me just one time again, let me write x, and this x was going to ax or xb or a or b. And for this, let me tell you, the language was, for this grammar, if this is your grammar, then the language will be a power m, b power n, where either m is greater than or equal to 1 or n is greater than or equal to 1. This was the language. And you can see this is a regular language. So the question was asking that, is it a regular language? This was regular language. And the regular expression, the question was asking for regular expression. So let me give you the regular expression. The language was this, a power m, b power n, where either m is greater than or equal to 1 or n is greater than or equal to 1. And in this question, the question was asking for regular expression. What is going to be the regular expression? So this was your regular language. This is a regular language, and the regular expression will be that you must have, I can say, a star, b star, at least one a or b must be there. At least one a or b must be there. Do you remember this question? And do you remember this option? This option was there. This option is correct. So this was a regular language. This language was a regular language, and the regular expression will be a star, a plus b, b star. Okay. Aryan, Irfan, this was a regular language. You can watch the analysis. You can you can go backward in the video. Okay. And you can watch. So the answer was this. So the language was regular, and this is the regular expression for this question. I can put this in the category of, I can say, tricky. I can put this question in the category of tricky, right? So this second question, the TOC question number 2, this TOC question number 2, I can put in the category of tricky, right? Correct? Okay. Should I put in the, which category should I put this question? This S goes to AXB X, and X goes to AX, XB, AB. The language is regular. The language will be regular. For this question, the answer will be, as I told you, the answer will be A star, A plus B whole B star. This was the answer. And I think we can, which category? Easy, hard or moderate? Which category? Easy, hard or moderate? Let me know. For this question, which category you can create? Easy, hard or moderate? So I can say. So first we will discuss all the TOC questions. So maybe I can put this in the category of slightly hard, like, because this was tricky actually. The question actually was tricky. In a Go Classes test series, I have prepared you for this type of questions. Okay, the question was tricky actually. The question was not hard. The question was tricky. And in the Go Classes test series, in the All India mock test, I have prepared you for this type of questions. I have already prepared you for this type of questions. Do you remember? Twinkle, Saurabh, do you remember? This type of question in the All India mock test, this type of tricky questions I have already put multiple times. Multiple times this type of questions I have put. This type of tricky questions. So the question was actually, I can say, tricky, or you can say moderate. But it was a slightly tricky question. Okay, let's move on. Let's see the question number 3. What was the another question in the third question was, this language was given to you that w belonging to 0 1 whole star and not consecutive 3 ones, not consecutive not consecutive 3 ones, not consecutive 3 ones. The question was asking for not consecutive 3 ones. And number of states, the question was asking number of states in minimal DFA. This was the very easy question. Like, this was really easy question. The question was asking for number of states in the minimal DFA. So for this question, if you notice, the answer will be 4. The answer is going to be 4. So this was actually very easy question, I can say. This we can put in the category of very easy question. This is a standard question. Okay, the answer is going to be 4. The reason, let me tell you the reason. The reason is very simple, because you can create this DFA. First, you can create the DFA where you are accepting consecutive triple ones. Okay, so if you have consecutive triple ones, then whatever comes you accept. Okay, so if you have consecutive triple ones, then whatever comes you accept. Then if you have 0, then you basically, if you have 0, then you wait for triple ones. If you have 0, then you wait for triple ones. Now in this DFA, you just complement this. Okay, in this DFA you just complement this. This will be your answer. So the answer will be, number of states will be 4. Number of states in minimal DFA, in the minimal DFA will be 4. This was your question. Very simple question. The question was not containing consecutive triple ones. 1 1 1. Not having consecutive triple ones. This was a very easy question. The answer will be 4. Do you remember any other question from the theory of computation? Is there anyone here who remembers any other question from theory of computation? Do you remember? Let me know if you remember any other question from theory of computation. 3 questions. I think these were 3 questions. Is there any other question from theory of computation? Please tell me. Anyone remembers any other question? Let me know. There was a closure property question. So there was a question that recursive intersection recursive will be recursive. Okay, it is true. It is actually true. I can say it is true. So recursive intersection recursive, that is true. Recursive enumerable intersection recursive enumerable, that is true. Okay, next, regular intersection regular, that will be regular, that is also true. And the CFL intersection CFL may not be CFL. Intersection CFL may or may not be CFL. Okay, it is equal to CFL is false. Is equal to CFL, that is false. This was your another very easy question. Again, I can put this in the category of very easy. Can you see, theory of computation was very easy. Very easy. So this was a question. You can notice context free grammar, intersection context free grammar. That may or may not be context free. Okay, context free language, intersection context free language, CFL intersection CFL, that may or may not be CFL. Okay, very simple. That may or may not be CFL. So this was a very easy question. Is there any other question that you remember from the theory of computation? From theory of computation, do you remember any other question? Any other 5th question do you remember? Let me know. So PDA question, so far we have seen 4 questions from theory of computation. So far, question number 1 that we have discussed PDA question. The question number 2 we have discussed this grammar question. This grammar question we have discussed. Okay, this grammar question. The question number 3 we have discussed this DFA, 4 states. The question number 4 we have discussed this closure property question. Is there any other question? There was a question. Yeah, okay. So that is compiler design question. So let me tell you, TOC plus compiler design, there was one question from the lexical analysis. From the lexical analysis, there was a question. From the lexical analysis, do you remember there was a question from the lexical analysis? In this question, basically the regular expression was given to you. The regular expression was given to you, and the regular expression was something like you. The regular expression was this. The regular expression was, you can go to followed by letter followed by either letter or digit. This is a standard question actually. Letter or digit whole star. Okay, so the question was asking for NFA. The question was asking which was the correct NFA. So this was a simple question again. So the regular expression is given to you. This regular expression defines the token. This regular expression, this defines the this is, I can say, for ID token. This was the regular expression for sorry for that. So this was a question for ID token. This was the regular expression, and the question was asking for NFA. You can very easily create the NFA. So if the letter comes, you can go to final state. After that, see, if the letter comes, you can go to final state. The first must be letter. After that, you can take epsilon move. Then you can, if the letter comes, you can go here, and if the digit comes, you can go here. Okay, and then you can notice that after that again you can go to empty epsilon move here, again epsilon move here. So this was your NFA. This was the answer. This was your answer. Another very easy question. This was the answer. Okay, so the biggest NFA was the answer. The biggest NFA in this question, the biggest NFA was the answer. So in this question, the lexical analysis, this question also was very easy. Very standard question actually. You will always see this letter followed by letter or digit star. This was the regular expression. First you must have letter, then you must have letter or digit whole star. Okay, so very easy. This was very easy question actually. So what other question do you remember? Do you remember any other question from theory of computation? Please tell me. Is there any other question from theory of computation that you remember? The other options in this question, if you want, let me tell you. The other options was something like this. There was one option in which you have letter, and then this is the final state, and something you were doing, like here letter was going, and here you have this type of self loop, and there was digit and this type of self loop. So this type of question was there. This type of option was there. So this option was wrong. Okay, so anyway, you can check it out. Any other theory of computation question that we missed? Please tell me. So far we have seen these theory of computation questions. These questions we have seen. The PDA question we have seen. The answer I told you. This grammar question we have seen. Answer I told you. There was DFA, minimal DFA question. 4 states. Closure property question we have seen. Is there any other? Yes, Aryan, we will discuss. The backend question. Liveness analysis question was there. I will discuss that. Do you remember? Okay, any other question from the theory of computation? Please tell me. Is there anyone here who remembers any other question from theory of computation? Or shall we go to the next subject? So in the theory of computation, we can close the chapter. In the theory of computation, these four questions are there that we have seen. One regular expression question was there. What was that? Yeah, okay. So there was one more question. The question number 6. Let's see the question number 6. This DFA was given to you. This DFA was given. DFA was something like this. Let me tell you the DFA. The DFA was something like this. On 0, you are going to the dead state. There was a dead state. On 0, you are basically going to the dead state. And then on 1, you are going here. Here you can take any number of 0. On 1, you are going here. On 1, you are going here. On 0, you are going here. This was your DFA. And for this question, the question was asking the regular expression. What will be the regular expression the question was asking? For this question, what will be the regular expression? This was the question. On your screen, I have written the question. This was your DFA that was given to you. This was a given DFA. And the question was asking, what is the regular expression, right? Yes or no? This was the question. Correct. This was the DFA. This DFA was given. Okay, so let me tell you the answer. But before that, please like and share with every student. See, you can see you are getting the correct trustworthy analysis. Okay, we are discussing all the TOC questions. So far, 6 TOC questions we have discussed. All the 6 TOC questions from theory of computation, all the questions were very easy. All the questions are very easy from theory of computation, and all the questions we have discussed. So please share and like and share with everyone. Please do that. Please do that. Like and share with everyone. Share in all the Telegram groups, in all the WhatsApp groups. If you are joined in any Telegram group or WhatsApp group, please share. Okay, so let's see this question. Now actually this question is very easy. What you can do? You can simply remove this. This state you can remove. Okay, this state, let's call this state Q. Let me call this state A. So you can remove this state A. What you can do? This is what you can do. Remove A. Remove state A. This is what you can do. Okay, just remove this state A. This state A, this is your state A. So if you remove this state A, then what will happen? Then 1 self loop will be there. See. Please see. 1 self loop will be there. So if I remove, then there will be 1 self loop. This 1 self loop will be there. Okay. This 1 self loop will be there. And there will be one path 10 here. There will be a path 10 here. 10 path will be there here. So there will be 10 path here. So you can remove this. Now you can remove this. Now you can just remove this. This is once you remove that state A. Once you remove that state A, now you got your answer. So your this was the final state. This was the final state. So now you got your regular expression. The regular expression will be 1 followed by 0 or 1 whole star. This is your answer. Okay. This is your answer. 1 followed by 0 or 1 whole star. So you can just remove this state A. This state A. Look at this state A. This state A you can remove. The final state was this. This was the only final state. Only one final state. This was the final state. You can simply remove this state A and you will get your answer. This was your question. So is there any other TOC question that we did not discuss? So I think TOC we have completed. Did we complete the TOC? TOC analysis completed. Right? TOC analysis is completed. Correct? Is there any other question? So what question we have seen? We have seen the PDA question. We have discussed. We have seen the DFA to regular expression question that we have discussed. We have seen the language minimal DFA state. Okay, minimal DFA number of states. That question we have discussed. We have discussed another question, that is this grammar question we have discussed. A, S, B, X, X going to AX, XB, something like that. This question we have discussed. Okay. So these 4 questions, and the 5th question that we have discussed is what else we have seen. So you can just check it out. Yeah, closure property question we have discussed. This closure property question we have seen. And this lexical analysis question, this lexical analysis to NFA, basically this NFA question we have discussed. Okay, so these 6 questions so far we have seen, right? Okay. Yes, PDA question we have discussed. Satyam is asking, sir, there was one question on PDA. Yes, that question we have seen. You can just go back in the video. Satyam, you can check. This PDA question we have discussed. These 6 questions we have discussed. Please tell me, what do you think? What is the TOC? What is the difficulty level of TOC now? Let's conclude TOC. I think the TOC was very easy. I think the only tricky question, all easy questions in this TOC, all easy questions. There was only one tricky question. Okay, all easy. There was one, I can say, tricky question, and that tricky question is this context free grammar question. ASB x goes to this. This was the tricky question, but this was also very easy actually. This was also very easy. One tricky question, but this was not a very hard question. This was ultimately overall TOC was very easy. Not even easy. The TOC was very easy. Ultimately, I can say the TOC was very easy. From TOC, you can easily get marks. All the marks you can get from TOC. This was very easy. Did we miss any question? Let me know. Okay. So, okay, let me, anyway, so I can say easy. Not very easy, but then definitely it was easy. Okay, it was really, I can say, TOC. Now let's see the next paper. Now let's discuss the DBMS. Let's discuss the DBMS. In this DBMS, what you had? Let's discuss that. Or maybe we can discuss compiler design first. So let's discuss the compiler design. Let's start with compiler design then. Let's discuss. What do you think? What is the first question? The one question that we have already seen. Okay, one question was lexical analysis. That question we have already discussed. So this lexical analysis to NFA. This question we have already discussed. This question we have already discussed. You can check it out. Okay, you can go back in the video and you can check. This question we have already discussed. Okay, you can check it out. Go back in the video and check it out. Okay, so this question we have already seen. What is the second question? Anyone remembers any question from compiler design? There was one SDT question. There was one SDT question. In that, something like this was there. I think something like I think 10011, something like that. Do you remember this? There was some string of this format, and what value it will return. Some SDT question was there. Do you remember? Anyone remembers what was the string? This hash was working as plus. This hashtag, this was working as addition. This was the addition. Okay, 10011, this string was there. And for this question, the answer was what? The answer, anyone remembers the answer? I think 2.375, something like that. Is there anyone who remembers this? 2.375, something like that was the answer. 2.375, something like that. Like the answer was this plus, let me remember, something like that, like some value divided by, okay, anyway, so I think you can check it out. I think this was the answer, 2.375. I think you can check it out, but I think this was the answer. Okay, so for this question, for this SDT question, the answer was this string was there. This was the given string. This was given, and the answer will be 2.375. This was actually very easy question. Just you just have to like solve it. There is nothing here. Okay, yeah, the answer was something like this, that you have 3 divided by 8, something like that. If you calculate, I think this will come. I think this is going to come, right? Yeah, okay, so this will come. So actually you can see that these are equal. So your answer will be 2 plus 3 divided by 8. The answer finally will be 2.375. What was another question in compiler design? In compiler design, what do you think about this question? This was easy question, right? Standard SDT question. This was a standard SDT question. This was a standard, like this question, really it was standard SDT question, correct? So I think this was easy because these are standard questions. Like in the GATE PYQs, this type of questions are already available. In the GATE previous year questions, these type of questions are already available. Many questions are available. You can easily solve this question. So this was an easy question. Now let's see the third question. Anyone remembers any other question from compiler design? There was liveness analysis question. liveness analysis. Loop was there. Context free grammar with control flow graph with loop. Control flow graph with loop. Do you remember this? I have taken in the, this is already available on the Go Classes YouTube channel. Anyone remembers this topic, control flow graph with loop? I taught you. Do you remember this? Especially I taught you this on the Go Classes YouTube channel. You can check it out. The link I will put in the description, but you can check it out. Control flow graph with loops, liveness analysis. Anyone remembers this from the Go Classes lectures of liveness analysis? And in the mock test also I put this question. Do you remember? In the All India mock test, let me just tell you this liveness question with loop basically. This liveness analysis. In this liveness analysis, the case of control flow graph with loop. Okay. So this, if you check on the Go Classes YouTube channel, you can find this. This concept, this complete concept you can study. This complete concept you can study on the Go Classes YouTube channel. It is already available. It is already there on the Go Classes YouTube channel. You can find this. Also, if you remember, do you remember in All India Mock Test 1 there was a question, in even All India Mock Test 3 there was a question on liveness analysis where this loop was there, control flow graph with loop. Do you remember? Go Classes All India Mock Test 1, Go Classes All India Mock Test 3, control flow graph with loop. Control flow graph with loop. This question I had already given, if you remember. So for this question, the answer, if you remember, the options were B1, B2, B3, B4. Some do you remember the answer? There was B1, there was B2, there was B3, there was B4. Let me tell you the answer. In two of them, there will be IJ, AIJ. In two of them, there will be AIJ. Okay, in two of them, two will have this AIJ, two of them will have AIJ, and two will have A, J. This will be the answer. Two of them will have AIJ, two of them will have A, J. Akash is saying answer was D. Options are shuffled. Akash. Options are shuffled. Like options, questions, all these things are shuffled. So I think you can check it out. Like I don't really, but I think this was the answer, that two was two of them have AIJ at the end, and two of them has A, J. This was the answer. Anyone remembers this question? Is there anyone who remembers this question? Let me know. There was a control flow graph with loop. The loop was there. In the question, there was a loop. Some control flow graph was given. There was a B4, there was a B3, there was a B2, something like that. There was a B1. Okay, and this type of loop was there. This type of loop was there. This question was there. Okay. Anyone remembers? Let me know. Anyone remembers this question? This type of loop was there. Okay, here you have some like, okay, anyway. So the point is, let me tell you the answer. The answer will be, this is just memory based question. So the answer will be two of the blocks. Two blocks will have AIJ. The answer will be something like this: AIJ for two blocks, and for one block there will be AJ. For two, okay. So there will be this type of option will be there. You can check it out. Two blocks will have AIJ, and two blocks will have AJ. Okay. Two blocks AIJ, two blocks AJ. Anyone remembers? Did you do this correctly? Please tell me. This question, did you do correctly? So anyway, the answer is two blocks have AIJ, live variables at the end, and two blocks have AJ, live variables at the end of the block. Okay, this was your control flow graph. So you can check it out. There was only one such option. There was only one such option where two blocks have AIJ and two blocks have AJ. You can check. Okay. Any other question do you remember from the compiler design? Any other question do you remember from the compiler design? Let's go to the DBMS then. Let's go to DBMS. In the DBMS, what questions you had? In the DBMS. In the DBMS, do you remember there was one question? So the compiler design was also easy, right? This compiler design, this was also very easy. In this compiler design, there were like this liveness analysis. This was the only, I think, maybe this question you have find hard, but this was already taught. You can check like on the Go Classes YouTube channel. If you have watched this lecture, this liveness analysis, if you have watched this control flow graph with loops, this type of concepts have already been taught. Okay, this type of concepts, liveness analysis, control flow graph with loops, and all these things. Okay, you can check it out on the Go Classes YouTube channel. You can check it out. Okay. So there was one question in the DBMS. There was very like stupid question. The question was asking for degree or arity. There was one question. The question was asking for degree or arity. So this question was there, degree or arity. This was a dumb question. Okay, degree of arity is the number of attributes. Let's see the DBMS. In the DBMS, one stupid question. DBMS was not easy. Actually, DBMS was stupid. Let me tell you. The DBMS, if you notice, we will see the DBMS questions, but DBMS questions were not easy. They were stupid. This DBMS in GATE 2023. If anyone asks you in DBMS in GATE 2023, how was that? So that was stupid. If you remember, there was one question where the question was asking the definition of degree. What is the degree of arity? Degree or arity. So that is the number of attributes. This was one question. A stupid question. What was another question? Let's see what was another question. Okay, so let's see another question. Let's see. In the DBMS, there was another question for 2 marks, SQL statement. A student table was given. This student table was given to you, and this query was there. This query was there that select star from student where the question was something like this, that gender is equal to female and marks greater than 65. This was the question, and for this question answer will be 2 rows. The table was given to you, the answer will be 2 rows. Okay, this student table was given. It was given. This student table was given. In this student table there was 5 rows. It had 5 rows. It had this student table, I think this had 5 rows, but ultimately the answer will be this 2 rows. How many females who have marks greater than 65? This was 2 mark question. Like literally, I think, do you remember how many marks for this question? Do you remember? This was a stupid question for 2 marks. For 2 marks this question. Do you remember the number of the marks for this question? Do you remember that? I think it was 2 marks. And the answer was 2 rows. Another DBMS question, anyone remembers? There was one question from the indexing. There was a question number 3rd, which was from indexing. In this indexing, if you notice, there was, I think 20, let me write the question, 25,000 records were there. Okay, and the question was like 100 bytes per record. 100 bytes, this was the record size. And what other things were there? 100 bytes, that was the record size to these many. And you can notice 15 bytes, this was the key size, primary key size. 5 bytes, that was the pointer size. Any other information? Okay, so I think this was the information that was given, and there was a block size 1024 bytes, that was the block size. This information was given in the question. Okay, and the question was asking that you have created, there is a data file and you have created a sparse index. So in this, what you had done, let me tell you that basically in this question, this data was given, and in this question some data file was given. Some data file was given. In this data file, what was happening? Something like this, like you have this data file. This data file you have, and there is an index file. You are creating a primary index. You are creating a primary index. In this index, this was a sparse index. This was a sparse index. So this type of sparse index you have created. This primary index, it was a sparse index. And the data that was given to you, that fix, this was unspanned organization. It was unspanned organization. This was given to you in the question. Unspanned organization. Okay, so this information was actually given, unspanned organization, and binary search you were using. So everything was given in the question. And finally the question was asking, so if you solve it, then how many number of index blocks will be there? Can anyone tell me? What will be the number of index blocks? Number of index blocks, I think that will be around 51 somewhere. Anyone remembers? I think that will be 50. Number of index blocks, that will be 50. So because you have number of index blocks is 50, so if you do the binary search, this was also given in the question. Okay, so the answer, that is 6. Okay, so for this question, the number of index blocks, how many index blocks are there? If you calculate, what was the answer? Okay, so somewhere like I think 50 index blocks were there in this question. If you calculate, you can easily calculate, like this data is given to you, you can easily calculate. Let me you can calculate. For example, 25,000 records are there, 100 bytes per record. So let's consider the data file. In the data file, how many blocks are there? Tell me. What is the number of blocks? So first you find number of records per blocks. What is the number of records per block? So that will be 1024 divided by 100, and this is unspanned organization. So because this is unspanned organization, so here your answer will be 10. So basically 10 data records per block. This will be your answer. This will be your, you can calculate. So there will be 10 data records per block. Okay, so you can calculate number of data blocks. Number of data blocks, that will be 25,000 records divided by 10 record. Okay, so that actually will give you 2500. This will be the number of blocks needed. So these will be the number of data blocks. These many data blocks you have, 2500. Now you can notice that. So what is the now let's see the index file. Let's look at the index file. In the index file, how many? What is the number of index entries? How many index tuples will be there? How many index tuples will be there? So number of index tuples will be 2500, because these many data blocks you have. These many data blocks you have, so 2500. Then you can finally see after this 2500, what you can see that you can calculate what will be the number of index blocks. So first you can see that number of index records per block. You calculate number of index records per block. How many index records you can put per block? In one block, how many index records you can put? So that will be 1024 divided by 20, because that is 15 plus 5 divided by 15 plus 5. So if you calculate this value, you can check it out. I think that will be okay. So how many index records you can put? So these many index records you can put 51. Okay, 51 index records you can put. So finally, number of index blocks. Finally, number of index blocks. So you can notice that these many you can put per block. In one block you can put these many. In one block you can put these many. So total you want to put these many. Okay, divided by 51. So these many index blocks you need. If you calculate this value, what that will be? Tell me, like if you do this calculation, so 2500 divided by 51, so that will be, if you take the seal value, that will be seal of 41.01 somewhere, so that will be 50. So 50 blocks finally you need. Okay, so finally you can notice there will be 50 index blocks. So if you do the binary search, the answer will be 6. Okay, if you do the binary search, then the answer is going to be 6. So for this question, the answer was 6. Is this clear to everyone? Please tell me. Let me know. Okay. So actually, nobody is asking that the answer will be 7. 6 plus 1. Actually, the question was only asking to, in worst case, how many index blocks you need to detect that record may or may not be there. Record to detect whether basically, so detect the block in which record may or may not be there. We just need to detect the block. We only need to detect the block. We don't need to fetch the record. We don't need to detect the record. See, the question was asking to detect the block. Detect the data block. The question was asking detect the data block. Okay, if the question, because the question is asking only detect the data block, you don't have to fetch it. You don't have to detect the record. So that is the reason answer will be 6. Okay, not 7. Any other DBMS question do you remember? Is there anyone who remembers any other DBMS question? From the DBMS, very easy questions you can notice. So far we have seen 3 questions. One was arity question, arity or degree question that we have seen. That is equal to number of attributes. How many attributes are there? There is another stupid question, SQL. For this question, there will be 2 tuples. There is another question, as we have seen this primary index. As we have seen this primary index question. Okay, so for this question, the answer will be 6. Any other question do you remember? From the DBMS. From DBMS, is there any other question you remember? Please tell me. 3 questions we have seen so far. Any other question do you remember from the DBMS? Anyone? Very few questions from DBMS, right? Only 3 questions from DBMS. Let me know. Do you remember any other question? Let me know. Ranchod Sansad is asking what was the overall difficulty level of the paper? That I have discussed in the beginning. Please go to the beginning of the video. Please go to the beginning of the video. Okay, please go to the beginning of the video. Only 3 questions from the DBMS. So DBMS, actually, you can see this is a dumb question, dumb question. This was a easy question. This was a easy question. So DBMS was actually easy and dumb. Like these 2 questions are really dumb questions. The first 2 questions, these are really dumb questions. Okay. So this is your DBMS. I think in DBMS there was no other question. Let me discuss some more questions that I remember. Let me discuss them. Do you remember there was a tag question in the computer organization? Let's discuss the COA, computer organization. There was a question tag question. There was a 8-way set associative. there was a set associative cache. The cache size was given to you in the question, that was 64 KB, and the information was given to you is a 32-bit physical address. The physical address size was given to you, that was for 32-bit. So basically the question was asking that you have tag section, there is a tag section, there is a index section, and there is a offset section, block offset section. So this was there. Okay, this was a very, very, very easy question actually. In this question, if you check it out, the answer will be, so it will be like answer will be, I think, 32 minus 13. Okay, so the tag bits will be 32 minus 13. I think it will be 19. Okay, so 19 tag bits will be there. This was a very, very, very easy question, extremely easy question, because the cache size is already given to you. Cache size is 64 KB. That simply means that you have 2 power 16 bytes. Okay, now you can assume like some value, you can assume that line size is, you can assume this block size or line size, you can assume that is 2 power m bytes, you can assume. Correct? This you can assume. This line size you can assume 2 power m bytes, you can assume this line size. So if you assume this line size, then what is the number of sets? Number of sets will be number of lines divided by, okay, this number of lines divided by 8. Number of lines divided by 8, because this is 8 way set associative. 8-way set associative means in one set, this is your one set has 8 lines. Total 8 lines you are there in one set. Okay, so total number of lines divided by 8, that will give you number of set. So here you can notice the number of set is 2 power 13 minus m. This is your, so finally you can notice that your address will be something like this. So you can notice that number of set that is given to you, that is 2 power 13 minus m. So your address that you have, that is 32-bit address you have. This is a 32-bit address. This is a 32-bit address. In this 32-bit address, let me call it x. This is 13 minus m, and this is m. So you can easily see that x plus 13 minus m plus m is equal to 32. So from here, x will be equal to 19. Okay, x will be equal to 19. Okay, so clear? So very easy, that because in the question line size is not given, just assume it. In the question line size is not given, size of block is not given, line size, this line size is not given in this question, this, so you can assume it. You can assume this, no problem. You can solve this question easily. Just assume 2 power m bytes of line, block size is 2 power m bytes, then you can easily solve this question. So for this question, answer will be 19. There was another computer organization question, pipeline. There was another question, pipeline question. For this pipeline question, the answer was like, you have 3 stages. There were 3 stages. So I think the 3 stages were like this. You have 3 stages. This, you have 3 stages. One stage have 20 nanosecond, one stage have some 11 nanosecond somewhere, and one stage have 40 nanosecond. So what is the cycle time? Tell me, what is the cycle time of pipeline? Anyone? What is the cycle time of pipeline? Cycle time of pipeline will be 20 nanosecond. Correct? For this pipeline, the cycle time will be 20 nanosecond. This is your 20 nanosecond is the cycle time. Now in this pipeline, 100 instructions you want to execute. You are executing 100 instructions. Okay, this 100 instructions you are executing. So you have to find the time. What is the execution time? So the answer is very simple. See, the first instruction will go through all the stages. The remaining instructions, this is for first instruction. So first instruction will be out of the pipeline after 3 cycles. Is this clear? First instruction, it will be out of the pipeline. In this question, the pipeline was given no hazards. It was given that there are no hazards. It was ideal pipeline. CPI was given to you as 1. In this pipeline, CPI was given to you as 1. Basically, in every cycle, one instruction is entering. In every cycle, one instruction is entering in the pipeline. In every cycle. Okay? In every cycle, one instruction is entering in the pipeline. There are no hazards. Now you can easily see that the first instruction will be out of the pipeline after 3 cycles. And the remaining instructions, they will come out of the pipeline in every one cycle. Okay, in every cycle, one instruction will come out. In every cycle, one instruction will come out. So from this pipeline, this is your pipeline. You can notice the first instruction will come out after 3 cycles. But after that, after the first instruction, the remaining instructions will come out in every cycle. In every cycle, the remaining instructions will come out. So you can notice this multiplied by these many cycles will be there. These many cycles. So what is the cycle time? Sorry, what is the execution time? Execution time will be this multiplied by 20 nanosecond. That is your 2040 nanosecond. This was a simple question. Answer is 2040. Okay, this is the question. Answer is 2040. So this was your COA question. Another question from computer organization. There was one more question from the computer organization. Assembly code was given. Let's see the question number 3. One assembly code was given. One assembly code was given and the question was asking like what is U1, U2, U3, U4? What are U1, U2, U3, U4? The question was something like that. Okay. So for this, let me tell you the answer. The answer will be for this question. Let me remember what was the answer. The answer was something like 3. The answer will be 3, 4, 4, L01. Something like that. Okay. So for this question, there was assembly code question. For this question, the answer will be 3, 4, 4, some L01. Like this was the answer. There was only one option with this. This was important here in this question. Do you remember this assembly code question? There was from the computer organization, there was one assembly code question. Let me know, do you remember this question? Do you remember this question? Very beautiful question, very simple question. Assembly language, assembly code question. Actually, let me tell you very interesting thing. This point, here many students are getting confused, I know. Okay, I think you may have done this. This was another option. This was another option, right? This was another option. This was another option. This option is not correct. This point I have discussed in our backend lectures. In the compiler design lectures, I have already discussed this. In the 3 address code lectures, you can check it out. On the Go Classes YouTube channel, go to the compiler design optimization playlist. There is a compiler design optimization playlist. In that playlist, you will find I was discussing this point. I was discussing. This was a very important point I was discussing. If you remember, okay. If you remember this, anyone remembers this point? In the Go Classes code optimization playlist, there was a code optimization playlist. You can check it out. You can go to the Go Classes YouTube channel, and there you will find compiler design code optimization playlist. In that playlist, this point I have discussed. This very important point I have discussed. So this was a simple question, 344, some L01, something like that. Okay, let's see another question. Is there any other question that you remember? Is there any other question that you remember? So there was one question on polling. I don't remember that. There was one question, polling question, but that was a big question, right? One polling question was there. So that was a very lengthy question. I don't remember it. Okay, so we can discuss that after some time, because I really don't remember that question. That was a lengthy question. It was a long question. Any other question in the computer organization? Do you remember? So there was one pipeline question we have seen in the COA. In the COA, what questions we have seen? Let me just conclude. One cache memory question we have. Oh, there was another LRU, that is LRU question, that is in the so anyway. So there is a cache memory question. Number of tag bits. This question we have seen. The answer is 19. Okay, so for this question, the answer is 19. Another question we have seen, pipeline. 100 instruction. For this question, the answer is 2040 nanosecond. And there is another question, this assembly code question. For this question, the answer is 344, something like that. Okay, something like that. This. So these three questions we have seen: cache question, pipeline question, assembly code question. Live variable analysis we have done. Lalit, compiler design. So far we have done compiler design, TOC, COA, and DBMS. Okay, let me tell you, if you are joining late, so far these subjects we have already discussed. TOC 6 questions we have discussed. Sorry, TOC total 5 questions we have discussed. Compiler design 4 questions we have discussed. DBMS 3 questions we have discussed. Computer organization 3 questions we have discussed. Total how many questions we have discussed so far? So you can check. Total 15 questions so far we have discussed. So far 15 questions. You can check all of them. You can go back in the video and you can check it out. You can go back to the video, go back in the video and you can check it out. Any other question do you remember? The live variable analysis question we have already seen in the compiler design discussion. Okay. Yeah, there was another question in computer organization on chip select. Yeah, there was a chip selecting, something like that. That was a very big question. Very big question. I don't really remember that question. Also, just let me tell you that please join our Go Classes discussion Telegram group for all your doubt discussion. If you have any doubt discussion, you can do all your doubt discussions in the Go Classes Telegram group. The link is in the description. Okay. So join Go Classes Telegram group. You can join for all your doubt discussions. The link is in the description. So you can check it out. Check out the link. Link is in the description. So you can check the description of this video. Description of this video you can check and you can join Go Classes Telegram group for all your doubt discussions. Let me tell you the username for the Go Classes Telegram group. You can join us on Telegram and you can discuss all your doubts related to technical, non-technical, any question you can ask related to Go Classes, related to admission, any query that you have, you can ask. Let me tell you the username. The username is @GATECSE _ Go Classes. Okay. So this link you can find in the description. Please check out the description. The link you will find. Okay. So you can just, this is already in the link. Remember, the link is already available in the description. So you can check it out. Okay. Let's move on. Ashish is asking how many marks top 100 people should get. I think more than 70, around 70 marks. If you want to get into top 100, then I think 69, 70, okay, more than 68, somewhere around 70. Okay. To get into top 100, you must get somewhere around 70 marks. Okay, let's see the next subject. What subject should we take? Tell me. So let's take any other question. Do you remember? Like, do you remember any other question? There was one question from the semaphore. Let me discuss some operating system questions also. There was one question from semaphore. There was one semaphore question. Okay, some L1, L2, something like that. Okay, V1, V2, something like that. Minimum value the question was asking. Binary semaphore, and there was one binary semaphore and another was this counting semaphore. Okay, so there was a question related to binary semaphore, and in the same question there was related to counting semaphore. This binary semaphore is S. Okay, this counting semaphore is this. So let me tell you, the answer will be 12 comma 7. This will be the answer. Okay, it will be 12 comma 7. It will be 12 comma 7. Okay, the reason is very simple. Let me tell you, this 12 is actually very simple. The binary case was very simple, right? Do you agree that binary semaphore case was simple? Minimum, maximum, everything will be this. In the binary semaphore, when you have S equal to 1, the minimum will be same as maximum will be same as 12. In this question, the minimum, maximum, everything will be 12. Okay, in this question, if you remember, there was a semaphore question in which you have total 5 threads. Total you have 5 threads of which are doing increment. So there are 5 threads incrementing, and there are 3 threads decrementing. 5 threads incrementing, 3 threads decrementing. This question was there. For this question, if you have binary semaphore, then the minimum, maximum, everything will be 12. Whether you have when you have binary semaphore, the minimum, maximum, that will be 12. And when you have counting semaphore, then see, you can bring it down to 7. You can basically neglect the minimum will be 7. You can basically neglect the complete effect of the plus that you can neglect. See what will happen. There are 3 threads. These are the incrementing threads. Let's assume these are the incrementing threads. These are the incrementing threads: I1, I2, I3, I4, I5. These are the incrementing threads. And there are decrementing threads. D1, D2, D3. There are decrementing threads. Now see, your counting semaphore value is 2. So what you can do, you can take a decrementing thread. In that decrementing thread, you can do this. It will wait on S. It will read X. X is equal to X plus 1, something like that. Okay, it will basically increase. Now, what you can do here, actually, let me tell you very clearly, this statement is like this. You will read X. This is not given, but this happens. You will read X into some register R. Okay, into some register R. This X you will read into some register R. Then you will do this R plus 1. And then you will put this X, this R you will put in X. This is what happens when you have this type of instruction. Whenever we have this type of instruction is not atomic, remember. Please understand that this type of instruction is never atomic. This type of instruction is never atomic. This type of instruction is never atomic. They are not atomic. So basically you will read this X into some register R, then you will increment, and then you will put this R into X. Okay. Now for this, you can easily see what you can do. This D1 can read. This D1, it can read X. Read X equal to 10. Okay, so basically it will read X equal to 10. Like this X equal to 10, it will read in the register R. Okay, in the register R, some register R1. So now this register R1 has value 10. Clear? This register R1, this has value 10. This register R1, this has value 10. Now you can notice that you can take this I1, you can let it increment. Okay, so now let it increment. So this is what you have done. Now let it increment. Let it done. Let this done. Let this done. Let basically all the incrementing threads you let them go. Okay, so let them run. I1 to I5. Let them run one by one. One by one, let them run. One by one, let them run. Your value will become what? Your value will become 15. Then what you do? Then this D1 will show its effect. Then D1 will continue. And then the D1 will write 9. Then D2 will make it 8. And then D3 will make it 7. So the answer will be 7. Clear? Is this point clear to everyone? So for this question, binary semaphore, this semaphore question, the answer will be 12,7. So this is your operating system question. This is the operating system question. And for this operating system semaphore question, the semaphore question, for this semaphore question, the answer will be 12,7. This will be the answer. Okay, is this clear? This was your operating system question, very simple question. Another question, let me randomly discuss this. In the operating system, do you remember any other question? There was LRU question. There was one LRU question. I'm not sure, like, I'm not sure. Okay, I can just like, I don't know. I'm not entirely sure, but I think the answer was, I think the answer will be 2 power 7 multiplied by 2 power, let me see, 2 power 7 multiplied by 2 power 5. I think the answer was 4096. I think the answer was 4096 page faults. Okay, you can like, you can check it out. You can check that question. I can write that question. Let me write that question entirely. So there was this LRU question in the operating system. Let me write it completely. There was one LRU question. So in this, one array is given to you, 128, 128. This is stored in row measure order. This is stored in row measure order. Okay, and there are 30 physical frames. There are 30 physical frames available. These many physical frames are available, all empty. Initially, all are empty. And this code was given to you. This is some code was given to you for I equal to 0, then I is less than 128, I plus plus. Then you were doing for this j was also going, this j was also going from 0, it was going to 128, it was going to j plus plus, and this was interesting that this you were accessing as AJI. This was interesting that you were accessing this as AJI is equal to something like that. Okay, you were basically accessing something like that, right? Something like this. This type of question was there, correct? AJI. This was important part, that this is AJI in this question. So this was a LRU question. Now in this question, actually, if you notice, very simple. It was a very simple question actually. It was a very simple question. And the question was already telling you that one physical frame can hold 512 elements. This information was given. 512 elements. 512 elements per frame you can put. Basically 512 elements. 512 elements per frame you can put. Per frame you can put 512 elements. This information was given. Okay. So finally here, if you notice, basically you were accessing like this. There were 0, 1 and so on 127. There was 0, 1 and so on 127. You were accessing like this. You were accessing 1, 2, 3, 4. The first 4 rows will go. Okay, so basically you were accessing like this. The first 4 rows. These first 4 rows. These 4 rows. That will give you one. These 4 rows will give you one page fault. Okay, so that will be your page fault number 1. Is this clear? That will be your page fault number 1. This is going to be your page fault number 1. Then what will happen? Because this is LRU, so it is happening like this. See, please see this like this. This question you look at like this. What is happening? Let me tell you clearly. Basically, you are accessing like this. You are going row wise. This is column wise you are going. This is 127. So first you will access the 4. Okay, these 4 elements. Then you will access these 4 elements. And so on, you will access these 4 elements. Now something interesting will happen. Something interesting will happen. You have only 30 physical frames. There are only 30 physical frames available. Actually, tell me how many you need. Can you tell me how many actually you need? See, 32 if are there, if you have 32, then the situation will be different. But because you have 30 physical frames, so what will happen? Here you have how many? Here you have how many? So tell me, here you have how many? Here you have 32. Here you have 32, basically like this. Okay, 32 times this will happen. Okay, and there are 30 physical frames. So because there are 30 physical frames, so and this is LRU. So what will happen? After this first iteration, when the first row will be over, when this first row will be over, this will happen. Something like this will happen. When the first row will be over, when the first row will be over, let me tell you what will happen. So after this first row is done, this will not be in the memory. This will not be in the memory. Everything else will be in the memory. Okay, so after this will not be in the memory. This will 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 be in the memory. Then after this, what will happen? Because you have LRU, because you are using LRU, so that is the reason. In this first also the same thing will happen. The same thing will happen again. Now it will be gone. Okay, so it will also give you page fault. See, all of them are giving you page fault. All of them are giving you page fault. So how many page fault you are getting? 32 page fault per column. 32 page fault you are getting for column 0. 32 page fault you are getting for column 0. So for every column you will get, actually each column will give you 32 page fault. You can check it out because this is LRU scheme. So each column gives 32 page faults. 32 page faults. So your final answer will be, number of page faults will be, that will be 32 page faults in every column multiplied by there are these many columns. So that will be 4096 page faults. Okay, is this clear? So this was another operating system question. Any other operating system question do you remember? Do you remember? Yeah, one multi-level paging question was there in the operating system. One multi-level paging question was there. The question number 4. It was multi-level paging. How many levels are there? The question was asking how many number of levels. What was the number of levels? How many levels were there? One was multi-level paging question and the question was asking for number of levels. Let me tell you, there was a multi-level paging question. The question was asking for number of levels. 57 bits was the virtual address space. Virtual address space was 52 bits, 57 bits. Something like that. So you can check it out, like how many levels are there. How many levels will be there in this? So there were 57 bits. Do you remember the data? Anyone remembers the data? What was the data? Do you remember? 57 bits were there in the virtual address space. And there were page entry size was there. Page table entry size was there. Page size was there. Page size was 4 KB. Okay, so that is page size. That is 4 KB. That was 4 KB. What else? 4 KB was the page size. Any other? What was the page table entry size? I think that was 8 byte. Okay, so this data was there. Any other data was there? I think this was the data. So you can just quickly solve it. You can solve it, and for this question you can just immediately solve it. So there will be like, you have this virtual address space 57. Okay, so 12 bits. This is your virtual address space. 57 bits. So there will be, this will be how much? wait so do you remember this, what is this, the exact data? 57 bits and page size 8 bytes. I think the answer will be 5 or 6. For this question, either the answer will be 5 or it will be 6. You can check it out. It will be somewhere like 5 or 6. The answer was 5 or 6. Okay. You just check it out. Like, I think the answer will be either it will be 5 or it will be 6. The number of levels, it will be 5 or 6. It will be 45 here. So you can check it out. On the first level, there will be 45 2 power 45 entries. There will be 2 power 45 entries. So how many pages? So 2 power 45 entries. So how many pages? These many pages. On the first level, this is your level number 1. On the first level, there will be, so you can just check it out. This will be like 2 power 36. 2 power 36 pages will be there. So on the second level, there will be 2 power 36 entries. On this level, there will be 2 power 36 entries. There will be 2 power 36 entries divided by this. Again, you can notice somewhere like 2 power this 2 power 27 pages. Then here you will have 2 power 27 page entries. These many entries divided by this. So that will be, I think that will give you 2 power 18 pages. Then here 2 power 18. Basically, I can say 2 power 18. 2 power 3 divided by 2 power 12. So that these many pages will be there. What is this value? I think that is 2 power 9. And then finally one more level. One more level will be there. That's it. So this will be the fifth answer will be 5. Okay. So for this question, for this multi-level paging question, this was question. And for this question, the answer will be 5 levels. The question was asking for levels and there will be 5 levels. You can easily do. This was the data. I have given you the data. You can check it out. You can solve this question. Easily you can solve this question. The answer will be 5 levels. These are standard questions. These are easy questions, standard questions you can easily solve. Any other question do you remember? So in the operating system, what questions we have seen? In operating system, we have seen the question of we have seen the question of LRU. We have seen the question of semaphore. We have seen the question of this starvation, scheduling algorithm. Okay. Also, we have seen the question of multi-level paging. Okay. So these questions, some questions we have discussed. So far in this lecture, in this video, these are the things that we have seen. Okay. Let me just conclude. In this video, in this session, what we have done, let me tell you, all the students who are joining late, what we have done in this session, what we have done TOC question discussions. We started first, we have done the TOC question discussion. Then we have done compiler design question discussion. Then we have done DBMS question discussion. We have done computer organization question discussion. We have done operating system question discussion. Right? Okay, so these questions we have discussed so far. TOC, compiler design, DBMS, computer organization, operating system. Some questions we have seen. Okay, so more questions we will discuss. More questions we need to discuss. So we will discuss in the next session. Okay. The remaining questions we will discuss in the next session. We will collect more questions from discrete mathematics, operating system. The remaining questions we will collect and we will discuss them. Okay. So far, these are the subjects that we have seen so far. Okay. The remaining questions in every subject, operating system, discrete mathematics, algorithm, data structure, okay, digital logic, aptitude, okay, basically all the remaining subject we will discuss in the next session. Okay, next session we will start within 15 or 20 minutes we will start. Okay, very soon we are going to start the next session. Okay, is this clear? Please tell me. Yes, there is a kernel question. Okay, so all those questions we will discuss. Discrete mathematics, remaining questions of operating system. Okay, as I told you, algorithm, data structure, C language questions, aptitude questions, all the things we will discuss in the next session. We will start the next session very soon. In 15 minutes we will try to start the next session. Okay, so in the next session we will do that. In the next session we will do discrete mathematics, engineering mathematics. These are the things we will do. Engineering mathematics, we will discuss aptitude. Okay, so these things we will discuss in the next session. Aptitude, also we will discuss operating system, remaining questions, algorithm, data structure, C language, digital logic. Okay, so these things we will discuss in the next session. Next session will start very soon in 15 minutes. Okay, please like and share with everyone. Okay, so the next session, let me tell you, the next session is starting very soon. Very soon we will start the next session in 15 minutes. In 15 minutes we will start the next session, and we will discuss some more questions. Okay, is this clear? Some more questions we will discuss. Please like and share with everyone. Let me know, was this session helpful? Please tell me. The analysis I have already given to you. In this session, actually, the analysis we have already seen. The analysis of paper, overall analysis we have seen in the beginning. Overall analysis we have already seen. So please go in the beginning. Okay, in the beginning you will find the overall analysis. Overall analysis in the beginning, then TOC analysis, then TOC questions, compiler design question, DBMS question, computer organization question, operating system questions. These things we have already seen. Please watch this video from the beginning. If you have any doubt, if you want to see all the things that we have discussed, all these things you can see. Go to the beginning. From the beginning you can watch. Okay, from the beginning you can watch. Overall analysis we have already seen. Those students who want to know what is the overall analysis that we have already seen in the beginning, please go to the beginning of the video and watch it. Okay, in the next session we will do all the remaining questions. We will do the remaining questions. We will do. Please tell me, was this session helpful? This session, this analysis, GATE 2023 question analysis, paper analysis, this session, was it helpful? Let me know. Please like and share with everyone. Like, comment and share. Okay, please like and please put your comment. Please give your feedback. Let us know in which question you made silly mistake. Let us know some more questions you can let us know. Okay, and please share with every GATE aspirant, with every GATE computer science aspirant, in your WhatsApp groups, in your Telegram groups. Please share with all of them. You can join Go Classes Telegram group. You can join. The link is in the description. Okay, so the next session we will start in 15 minutes. Then we will discuss the remaining questions, and check out the description. Okay, in this video you just check the description. In the description you will find Go Classes Telegram group link that you can join. If you want to prepare for GATE 2024 exam, if you are GATE 2024 aspirant, you can join Go Classes GATE 2024 complete course. You can join. Similarly, if you are GATE 2025 aspirant, you can join Go Classes GATE 2025 complete course. All the links are available in the description. Please check out the description. Okay, you can download Go Classes Android app. So you can visit the Go Classes website. Just visit the Go Classes website and you can check. You can join GATE 2024, GATE 2025. You can download our Android app. Okay, all the things you can see. And if you have any doubt, you can ask us. You can send us a mail on the Go Classes website. On this website you can go and you can find our email ID. You can send us a mail if you have any doubt, or you can join our Telegram group. The link is in the description. You can ask all your doubts in our Telegram group. Okay, so we will meet in 15 minutes. Okay, after 15 minutes we will start the next session and we will discuss the remaining questions. We will discuss all the questions. Okay, today, by the end of tonight, I can say by tonight, each and every question we will discuss. We will give you the answer, the analysis, everything we will give you. Okay, so thank you everyone, share with everyone.